Hi everyone, today we will solve this question, count element occurrence in a sorted array. So we have given this sorted array and we have to figure out how many times this key has occurred, right? For example, this 3 has occurred 4 times, right? So the answer should be 4. So one simple solution is you can iterate over each and every element of the array and compare each element with the key. If it matches with the key, then you can increment the count and at the end you can return the count. Since you are touching each and every element of the array, so complexity of this will be big of n, right? So we given this array is sorted, right? So we are not really taking the advantage of that, right? And so we can, like, whenever we have given sorted array, we can apply the binary search. Like we can think of, at least think of applying the binary search if that solves the problem. So here, let's say, like in binary search, we divide the array into two halves, right? We calculate the mid. So let's say this is my mid, right? And key matches with the mid, right? So what we'll do is like first find the mid, right? So here we have mid right now. What we'll do is we'll go in both the directions, right? We'll run one while loop. We'll go on the right side till the point we are getting the same key, and similarly we will go on the left side and will stop when we'll get the different key. So something like this. So for example, if your array of mid equals to key, if it matched, right, what you can do is you can, let's say, your temporary variable, like temp equals to mid, right? Now you have to go on, let's say you have to go on the left side, right? So what you can do is if your array of temp equals to key, if key is same as the, then what, since we are going on the left side, right, we have to go till we get the greater than I greater than 0, right? And every time we'll be decrementing the I and we'll be incrementing our count, right? This is one while loop to go on to the left side, right? Now we'll have another while loop if array of, again, like we'll have to reinitialize temp mid plus 1, right? Array of temp, what do you call, equals to key, and this time we are going in the right direction, right? So temp should be less than end, right? And again we'll be incrementing the temp plus plus because we are going on the right side, and we'll be incrementing the count, right? So at the end we can return the count. So in this case we are applying binary search, no doubt, but at the same time we are running two while loops, right, which are going in the left side and on the right side. So in the worst case complexity will be O, worst case will be like if all the array elements are same, right? So in that case you will end up touching all the array elements, right? You will be end up visiting all the elements. So that's the reason in worst case the complexity will be big of n, right? Now one more optimal solution is, so what we can do is if we apply binary search smartly, like if we figure out the first time when this element occurred and the last time this element occurred, right? Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So now this element occurred at fourth position, right? And last occurrence is, and if we do plus 1, um, 7 minus 4, 3 plus 1, 4 times it occurred, right? So basically idea is to find the first position of the element, last position of the element, then do last position minus first position plus 1. Okay, so let's see the code, then you will get better idea. So So we'll just fill up this count occurrence method, and start is 0 and end is array of length minus 1. And in binary search what we do is we run the while loop from start less than end, right? And we calculate the mid will be start plus and minus that, right? So now what we have to see, if array of mid equals to element, right? So now let's see, we have to figure out the first position, right? We have to find out this position. So no matter what, even if it is matched, we have to always go on the left side, right? Here we are talking about the first position. If mid equals to element, then we will always go into left side and will be mid minus 1, right? And at the same time we will update our first position to mid, right? Now what we are going to check is, if our array of mid, if our element is greater, right? If element is greater than mid, right? Basically if mid is not the key, right, then we have to see, we have to search for the key in left direction or right direction, right? If key is smaller, here in this case, let's check it this, if key is smaller and mid is greater, then we will update our end, right? Else we will update, will search in the right side. Cool, right? Now we have to perform one more search, and this time we have to search for the search on the right side. I mean, we have to find out the last position of the element in the array. So I'll reset my start and I'll reset my end. Okay, I'll just format it. My end will be array dot length minus 1, right? So we'll slightly modify this logic. I'm new to this editor, so keyboard options are probably slightly different here. Doesn't work. Okay, anyways, so we have to go on the right side always, right? So even mid matches with the key, right? We will always do start equals to mid plus 1, because we always want to go right and figure out the last position. Last position will be mid, and here we'll be updating our start mid plus 1, right? Rest everything should be same, and here it will be last position minus first position plus 1, right? And let's say if for negative case, if the key itself is not there in the array, right, then our this first position itself will be minus 1, right? So in that case we can simply return 0. So we'll quickly check the code. This looks fine. Okay. Yeah. So let's see, we search for 3, right? 3 has occurred 3 times, right? Now let's try to search for minus 5. Minus 5 occurred once. Something which is not there in the array, 10, right? It's 0. It's working fine, right? So since we are applying binary search, so big complexity will be O of log of n. Okay, thanks for watching.